Hello?
Hey everyone, we're just doing a quick mic check and everything. We'll get started on the hour.
Let's try to
You want to try
go
and share
ahead.
your screen real quick?
Yes, let's try.
I see it perfectly fine now.
Yeah? Oh, okay.
Let me check the chat real quick. Can everyone else see the screen? Okay, we're gonna.
Thank you, Matt, also for streaming it on YouTube.
Oh, that's awesome. Appreciate it. We're gonna pray to the Discord gods that we don't run into technical issues next time, but we might be in the clear. Famous last words though.
Yeah.
Okay, we are at time and we already have a good amount of people here, and it looks like David, you already started the event, so thank you, appreciate it. Um, oh, nice, love that. I could see the like live reactions in Discord. So first of all, thanks everyone for joining. Appreciate everyone's time. This is for or second of many future events around blueprints. For those of you who are unfamiliar with blueprints, they are like open source building blocks for AI applications, and we've been building them for a few months now. And we started with like documented podcast, and now we have a few more that we released. And we'll be speaking about two of those in a bit more depth and going kind of a little deeper in a technical walkthrough and demo of a couple of them. And Costas and David are both engineers that worked on two of these blueprints. This is meant to be kind of an informal and interactive session. So if you have questions during kind of the presentations and walkthroughs, please leave them in chat and we'll be sure to kind of address them. Um, yeah, and then logistics wise, the two blueprints we'll be talking about are structured Q&A, and then speech to text fine tuning. So from here, we also have Stefan, who's a product manager on the Mozilla AI team, who helped facilitate a lot of these creation of these blueprints. So he'll be able to answer questions. David is going to try sharing his screen briefly, and then we'll see how that goes. Uh,
The screen is still loading for me. Yeah, for everyone.
Same for me. David, if you potentially lower the frame rate.
Otherwise, I can go first if you're having
Yeah, why don't we
difficulty.
try Costas first, and we could kind of adjust course if needed.
Cool. Let me see if what's going on. Does it work? Can you guys see my screen? Nice. Okay. Cool. So I'll give a little presentation on the latest blueprint I've been working on, which is basically a beginner-friendly guide on fine-tuning and running locally speech-to-text models. So for context, speech-to-text models, as the name suggests, get audio as input and produce transcribed text as output. This task is also known as automatic speech recognition. So how come we pick that? In the past year, as you've probably seen, open source LLMs are getting almost as good as closed source ones, but in the speech to text model space, things are a bit tricky. Benchmarks are even less established than in the LLM space. There aren't many great multilingual benchmarks, not much information about performance between closed source and open source is available, but you can get from like a quick vibe check of these speech to text models that they struggle in non-normative settings. So for example, in non-English languages or in non-normative voices, like people with non-native accents or with speech impediments like stuttering. So this was kind of the foundation of this blueprint. How can we enable the open source community to close this performance gap and empower developers that do want to work with low resource languages or non-normative environments? So this project kind of consists of three components. The first, we wanted an easy way to vibe check any open source speech to text model and do that locally. So this is the transcribe app. The next component was the fine-tuning script. So that kind of enables people to run fine-tuning jobs and to improve the performance of speech-to-text models on low-resource languages. And then we have another very simple app that enables users to build their own speech-to-text datasets. We'll see soon. And the main point here that all of this happens with no external APIs, no data leaving your machine, your privacy is preserved. So the transcribe app is this one. Let me see if I can do a live demo. It worked just now. So here it's running locally. So I'm selecting a model from the drop-down. We have the default from Whisper models from OpenAI and some of our fine-tuned versions. So I'm trying, for example, Whisper Small, it's a multilingual model. I put this audio clip from David actually speaking Galician.
O Comité Económico Social Europeo deu luz verde.
I won't play all of it. So you press transcribe, the model is loaded locally, and you get the text. And the nice thing here is that you can also select like another model. You don't have to do anything again, just click transcribe and get the text output of a different model. So it's relatively easy to vibe check the performance across different models. Again, here, I mean, there's a million apps like this on Hugging Face, but the main focus here was that to make it super simple to run it locally, so that you don't send your voice over the internet to a server that you might not trust, for example. Next component was the fine-tuning script. The first point was, okay, what models do we want to support? So we check like, okay, what is state of the art in open source speech to text? And this is like the leaderboard on Hugging Face right now with the top 10 models. So, okay, cool. NVIDIA seems to have some pretty good open source models. But if you look a bit closely, these models are trained on proprietary data, like a big chunk of them is proprietary data. And also some of the models have non-commercial licenses. So this didn't quite match our standard for like an open source model. So the next potential model is actually from OpenAI. It's the family models called Whisper. And they released that back in 2022 when their name meant something actually. Their their license is permissive licenses and Apache 2, which is nice. And their training data is all open. It's like a big mix of public data sets like LibreSpeech and Common Voice and stuff like that. A few details. The model architecture is like a transformer, encoder, decoder, or like sequence to sequence model. Together with transcription, it can do language recognition so that it recognizes what language it listens. And it can also do translation. So it like you can select, you put in the listen and it translates to English, for example. But the important thing here is that it comes in different model sizes. So like the tiniest version is like 39 million parameters, which can run on like almost any laptop. And the biggest one is 1.5 billion, for example. Yeah. Some other data about the training data, I mean, it's a big mix. Most of it is still English, not audited, this data. And only 17% is with non-English transcribed text. But okay, it still has like 98 different languages, which is a good base to start for fine-tuning. And something that they have on their paper, which totally makes sense, is that the performance on transcriptions in a given language is directly correlated with the amount of training data of that language. So, data selection for fine-tuning. The obvious choice here is Common Voice and from Mozilla. For those who don't know, it's like a free open source platform for community-led data creation. Anyone can go and record or validate existing recordings. Oh, thanks, new chat. I forgot to change. Yeah. It's a huge global and very active community. There's more than 130 languages supported. They have quarterly dataset releases. And their recordings are like from diverse speakers in diverse environments. So like recordings can be from like super high quality studio microphones to really old phone recordings. And this is not a bug. It's a feature actually, because that kind of enables the model to do well in all kinds of environments. So the next thing that we did is to like create a very simple configuration file that you can adjust the parameters however you want. We have extensive documentation on that on the repo. Just one nice feature here that I want to mention is that optionally, you don't have to. You can, if you have a Hugging Face account, you can log in and so that you can track in real time the training metrics and also uploading directly automatically your model at every checkpoint, which is nice for long fine-tuning sessions that can take many hours. And after you set that, all you have to do is like run a script, and it starts the fine-tuning job. And that can either happen in your laptop or your machine server, whatever. For example, I trained Whisper Small on Greek on my laptop that didn't have a GPU. It's like a 4-year-old laptop. One thing to note is that, like Greek is a relatively small data set. Other days can grow up to like 50 gigabytes or more. So be aware of that. You can also run our repo directly on GitHub through code spaces. They don't have a GPU, but you do have a few free CPU compute hours. And we also have a Google Colab that you can actually use a GPU. Yeah, again, there's a little be aware
Costas,
here.
I have a question.
Yeah.
How, how much data do you recommend collecting before you start the fine-tuning process?
You mean with your dataset app?
Yeah, yeah.
Okay. Can I answer that a bit later?
Oh, sure.
It makes sense. So next, I put kind of in the last part the data. Okay. Before that, I want to mention like some results that we had. So in our team, it's me that I speak Greek. We have David that speaks Galician, and we have Stefan that speaks French. So we first fine-tuned models on these languages from Common Voice so that we can easily vibe check how they're doing. And actually, the Galician community of Common Voice is huge. So there's like lots of data there. So that model is doing great after fine-tuning. And then I've had here the datasets app, which it's like super simple. Basically, you write your text in whichever language you want, and then you record your voice reading out that text. So if you do it multiple times, this is how it looks like on the right side. You have like a bunch of audio clips with a CSV file with the sentences and the index. And this can be useful, like some use cases, like if you want to create a data set that is not on Common Voice or like doesn't have many samples on Common Voice, or you're working with accents that are not very common, or with voices with speech impediments like stuttering. That's it. That's kind of the introduction. We would love any feedback. I have a bunch of interesting ideas. There's so much work you can do on this. I have a bunch of issues here that I've tagged with help wanted or with first issue if you want to tackle anything. Yeah, and I'll go to your Q&A and I'll start with Alex. So kind of the flow that I've been thinking is that, okay, you're a user, you're like, I want to use speech to text models like with my Home Assistant, for example. But I don't want to send my voice data to a server I don't trust. So I want to run it locally. So what do? You first open up the Transcribe app. Yeah, the Transcribe app. You test some existing models, and then if you have the hardware, you start a fine-tuning job on the Common Voice because you can do it with laptop with a small model, but if you have also better hardware, you can pick a bigger model, or like if your language has lots of samples, like it's not a very niche language, then you might it might take a long time the fine tuning job. And then kind of as the last resort, you go into making the data set yourself, because you will still need to make a few data, and it is a bit laborsome to make your own data set. So I've kind of left that as, okay, the last thing you kind of do in the flow, if ever anything else doesn't satisfy you, if that makes sense. Yeah. If anyone else has any questions, or yeah, I guess we can take questions now and then do the. Let me see the chat. Yes, that Greek whisper model is open sourced. All of the models. These three models are. I'm currently fine tuning on Swedish, and maybe we'll have, like, if there's demand, maybe we'll do some other. We'll publish a few more models, maybe in different sizes. We'll see. Personalized datases. Benji, I'm reading your question. Is the Mozilla team potentially accepting the personalized datasets to join the Creator Common Voice datasets? Yeah, so the one I'm guessing you mean the ones that you create through this dataset app. I've talked with the Common Voice people about it. They're not accepting data created outside of their app as of now. I don't know how much. I think no. I think it's common knowledge. No, they are planning to release at some point an API. They've said that publicly, so that's fine. I don't know when, but when the API gets released, we can see if they allow that we also send instead of just downloading data from the API, for example. Right. Okay. Benji saying that they're currently in the process of doing both sending and requesting. Yeah, I'm also looking forward to that feature. Let's see. If there's no other questions, I'll throw it to you, David, maybe.
David, if you're speaking, I can't hear you.
Is he gonna try and rejoin real quick?
Yeah.
Hello, hello.
We hear you now.
All right. Let me then try to
I
share.
don't.
Maybe.
Oh, damn.
Oh, you.
I do.
Okay.
Try and share. If not, I can try sharing from my screen as well.
All right. Please share. Can you share your screen, Stefan, with the slides?
Yeah, one sec. You see that okay?
Yeah.
Yep, I see it.
All right, cool. So I'm going to talk about another blueprint, which is called a structure QA from question answering. And I'm going to start by introducing also what was the motivation behind working on this. If you can click next and next. So basically, I like to play board games. We were thinking about useful, cool ideas for working on a blueprint. And I find myself, I am not afraid of saying that I like to play with the rule book next to me and discuss every time there is a question. I just go and check the rule book. So I thought it was kind of cool to try to make a small app so I can just verify quickly what someone is proposing as a rule, and I can double check against the rule book and don't have to do this manually. So next one. And then the structure part of the blueprint comes from researching the existing solutions about question answering. They all seem to assume that you have like 1 million documents, and to answer a question, you have to consult all the documents and kind of like make some connections to find the answer. But in my own experience, if you go to the next slide, the reality is more like there are a lot of well-structured documents out there, like technical documentation. This is a screenshot from the CUDA C programming reference. Like humans have put a lot of effort into structuring the document in sections. So I wanted to explore a solution that doesn't assume that you have 1 million documents, more like you have one document and it's well structured, what you can do to implement question answering. Next slide. So the first thing we did, we collected a small benchmark using this assumption. You have one document, maybe it can be a research paper, technical documentation, a board game rule book, and we evaluated the two existing solutions or main solutions that you can try today. First of all, you can just feed the entire document to the model. This is called the full context approach. And as you can see in the results, it only really works with models that have a really long context window. In this case, we evaluated Gemini, which has like a huge context window, so it has great performance. And on the other hand, the local model cannot fit most of the documents, so the performance is much lower because for most of the documents, they don't fit into the long context window. It looks like there are some issues. All right. Thank you, Kostis. And then the other approach is like using a RAG system, retrieval augmented generation system. And you can see that there is already a performance drop for the Gemini model compared to the full context approach. But is the only really viable solution for a local approach using a small open source model. So next slide. So we decided to try to implement an alternative to these two approaches, either using full context or a RAG system. And we released it in this blueprint, the structure QA blueprint. It works in 3 steps. Well, 1 step and then 2 steps in a loop. So the first one, it pre-processes the document to extract the sections, like kind of the index that I showed before for the CUDA C programming. And then it splits the document using these sections. Then we have a loop where the model is first asked a question and provided with the list of sections available, and you tell the model, can you please identify in which section do you think is the answer? Then we retrieve this section manually. We just load the chunk manually, and we feed it again to the model, but now providing that section as context. If the model cannot answer from that section, then we go back again to try again and find a different section. And I think this kind of mimics how we humans approach answering questions. I find myself going through the index before diving into the rest of the pages. Yeah, next slide. So this method, using a powerful model like Gemini, works, has an equal performance to Gemini. And there is a small drop in performance compared to a RAG system. In this case, Ragatouille was the system we were using. And this small drop of performance actually comes from the use case that I care about, which were board games, which is kind of unfortunate because, next slide. Okay, never mind. I have it. I think I have it later. Anyway, the problem with board games is that they are like not really text based structure. They are like have weird visual layouts, and the model really struggles to extract all the different sections. So this method works for most of the cases, like research papers and technical docs, but struggles with board games, unfortunately. And here I just put a comparison of what are the different approaches that you can use using open source and a local model. So you can go with RAG, and there are already quite a few moving parts. You need to have, like, obviously the LLM inference with the context that is retrieved. Then you need to pick a RAG framework, and within the RAG framework, you need to choose a chunking strategy, embedding strategy, and retrieval strategy. There are approaches that build on top of RAG and in order to improve performance, like agentic RAG. To me, this only adds like a more complex moving part on top of the already complex system like a RAG. And it also requires a model to be capable of doing actually function calling properly. So many of the small open source models actually struggle with this, so they are not really suitable for this approach, unless they are fine-tuned specifically for this. On the contrary, even though the performance is lower for board games, what with releasing the blueprint is basically just, you just need LLM inference, 100 lines of code that define the find, retrieve, and answer loop, and the pre-processing where you chunk is defined by the sections of the document. So no decision there on the chunking strategy, you just take the sections. Next slide. There are some open issues that you can check in the link in order to prove this. There are a couple of ideas like trying an alternative PDF to Markdown conversion to help improve the performance on board games. And then a couple of other issues, you can check them out and contribute. Next slide. And here is where I put the slide of showcasing what a board game rulebook typically looks like. And this is the part where the model, it's not the model, is the pre-processing step is struggling, which is to extract the sections from this visually complex layout. Yeah, next slide. I think, yeah, you can check a live demo here on Hugging Face if you go to the link. I don't have any more slides, I think. Yeah, you can just upload your document and then you will be prompted to ask a question about it. Yeah, that's it. I don't know if there are any questions.
Did it make you better at board games, David?
It made me better at winning arguments.
And that's most of the battle anyway, board games anyway.
Yeah, and that's the important part.
I know we had originally potentially looked at like a potential like agentic workflow. What made you kind of not go down that route from a technical perspective?
Yeah, so I mean, first of all, I wanted to see how far you can get with a simplest possible solution, right? But then there was also what I briefly mentioned is that many of the small open source models are not really trained to make function calling properly. So most of the agentic frameworks assume that the model is capable to understand the instructions on how to call tools, but it turns out this like less than 8 billion parameter models often struggle to make the right syntax for the function calling, and the agentic framework just breaks because it doesn't get the right syntax. And I tried several ones, and they were really struggling. In contrast, in this blueprint, all you tell the model is like, if you don't find the answer, just return I need more info, and this instruction is simple enough for the model to follow. It doesn't have to match a specific syntax. Yeah.
Got it. No, that makes sense.
Right, cool.
Any questions from the audience? Yeah, we are, I would say, ahead of schedule on blueprint development. So we actually have some more coming out this week, and we have some community members working on some additional blueprints too. The one that is, I think we're starting to talk about a little bit more today is like an OpenStreetMap AI helper, which David released, which is really interesting and a bit of a different sort of use case than some of the LLM ones. And I think on the 19th currently, we have a blueprint brainstorming session, and we'll kind of have like a informal Discord session where we'll talk through some ideas around blueprints. So feel free to join. I think it'll be really interesting and fun. And as always, feel free to add any comments or questions in the blueprints channel itself. We now have a dedicated space for that in the Discord that Matt was able to set up. So we're very active on Discord, so happy to answer any questions. If there are no more, I think we could end the session a little bit early. Thanks, everyone.